Welcome to this video on managing OpenShift resources. My name is Ashish Saket. I work in Red Hat as a Senior Technical Account Manager. So let's get started. So I'll be trying to explain these key resource objects and their configurations. With an example of an application deployment, I will try to set up the resource limit for that deployment. I would want to scale up or scale down based on the load on my application. And as an administrator, I will restrict this application by defining limit ranges and resource quota so that this application doesn't consume the whole cluster resources. So this is the OpenShift cluster that I have in my demo environment. And this is a demonstration application, Node.js application. All the logic is there in this app.js file, which says that this application is running on 3000 port unless an environment variable is set. So apart from that, this application is just printing a log line, and it will tell that where the request is received from, with using what method and from which URL, and it will go for a sleep for 5 seconds, and then it will return back with a message, hello world, from Node.js. I have put the sleep just to create some load on the application. Okay, so let's pick up the GitHub URL for this application. And I go back to the cluster. I go back to the developer perspective and I create a new project for my application. Suppose NSApp Node.js. In this application namespace, I want to import my application code from Git. So using OpenShift S2I feature, this code will be imported, and using the base builder image of Node.js, it will create a new image. So that's why it is called source to image functionality of OpenShift. So using that, I'm importing this code. I'll leave all the configurations as default except the target port. We know that this application is running on 3000, is exposing the 3000 port. So rest all I will not set up right now, but if you see, there is an option of setting resource limit here as well, that I will do later. And you have different Kubernetes resources, pods, builds, services, and routes. So the route has been created and the pod is running now. If I click on the route, it should try to hit the application. After waiting for 5 seconds, it should return back the response. I will go to the pods to check the logs. So I see there was a hit already. I'll try to refresh the browser to get the message. Yeah, so the message is there. So it has hit the application, my application 2 times. So every time I hit this application, there will be 2 log requests coming up, one from the URL and one from the favicon icon, which is as expected. Alright, so I go back to the deployment and I see that this application is now running with 1 pod. I can increase manually the pods if required, but that's a manual effort. So later I will try to set up a horizontal pod scaler on this. In order to set the horizontal pod scaler, it is important to set the resource limit first for this application. If I see this pod metrics right now, so it is consuming, so there is no data point yet created for CPU users because it's just started. For memory users we got some data points, so it is currently using 36 MIB memory. So looking at this, I will try to set some resource limit for this. I go back to the namespace that I created. I will try to set the resource limit, and here I can say that I want 20 millicore. This application should start with a CPU request of 20 millicore, and it should not go beyond maybe 50 millicore. Similarly for memory, I will set up 32 MI and 64 MI. So with these resource limit, the pod will restart and this limits are now set. By setting the resource limit, I am constraining my deployment so that it does not use the OpenShift resources beyond a certain limit. Okay, so if I see the metrics now, you see the memory users is 39.65 MIB, which is in between the requested memory request and limit. And similarly the CPU users is also very low, so it is showing no users available, although the request was 20 millicore and 50 millicore. So the usage is very low. Now I don't want to manually scale out this application if the load increase. So basically if the load will increase, I will set up a horizontal pod scaler. This is the horizontal pod scaler object configuration form, where I'll give the name of this HPA as HPA Node.js, and I want to define that the minimum pod should be running as 1. I cannot make it 0 because the minimum pod has to be running as at least 1, and the maximum pod can be up to your requirement. So right now I have set up as 3, and I will say that upon reaching 75% of the CPU utilization, it should start scaling and to a max of 3 pods. So that's all. I will save this HPA. You see the HPA gets created as another object with the configuration we just defined. So the target CPU utilization should be 75 before the scale up can happen. So this HPA also gives the current utilization. So the current utilization of this pod is right now 5% or 0%, where the target is 75. So we can see this in a CLI also. So I am going to watch. Let me go to the project first. And I will be watching the HPA we just created. So here we see that the current usage is 5% and the target before the scale up happens is 75%. The minimum pod is 1 and the current replica is also 1. The maximum that it can go up to is 3 pods. So I have a script to create some load onto this application. So the URL, I will try to hit this URL multiple times through a script. Just to create some load, and then we will see that the load will slowly increase. It should increase, and once it reaches beyond 75%, the replicas will increase from 1 to up to the max of 3. So we will see the CPU utilization has reached to 225%, and the replicas has also started increasing. It went to 2 pods and it will further go to 3. If we see this pod matrix, you see that limit has been reached. We can also see the observe tab for this namespace, and we see for all the pods in this namespace, you see the utilization slowly went up, and then more number of pods got created, and then the load was reduced. So because there were more number of pods running, and then the load was removed, so the pods also got removed. This is the memory graph. So slowly the memory also increased, and then 3 pods got created, and then slowly the load was removed, so the pods will be removed. So I come back to the CLI. I still see that the 3 pods are running. This is happening because of the stabilization window configuration. To demonstrate this scale down behavior, I will change the HPA that we just defined, and we are going to add some scale up and scale down policies. So I'm going to add the behavior, scale down behavior and scale up behavior. In the scale down behavior, I'm saying that the stabilization window is 30 seconds. So after the 30 seconds, it should start reducing the replicas, start reducing the pods. And I'm saying that with every 30 seconds of interval, 1 pod can be removed. So if 2 pod will be removed, it will take 30 plus 30, 60 seconds to remove both the pods. Similarly, for scaling up, there is a stabilization window. So I'm saying that let's scale up immediately upon receiving the utilization threshold. And for scaling up, HPA should scale up every 15 seconds, a max of 4 pods, or every 15 seconds, a max of 100% of the current number of pods. So what out of these two policies, which will take in effect, which will impact the maximum number of pods? So this is a way of selecting between multiple policies that we define under scale up or scale down behavior. Right, so this object has been updated, so I'll have to reload first, and I will have to paste this configuration again and save it as fast as possible. So the new changes has been applied to the HPA. By that time, we see that the load was removed, and after the stabilization period, the pods were automatically scaled down to 1. Now I go back to this window and I'll try to create the load again for 60 seconds, and now we see the scale up will happen as previously, so it will immediately happen once the target utilization threshold exceeds. We see that number of pods has come up immediately. Now we are running with 3 number of pods. which will also show in the HPA metrics. So now there are 3 replicas running because the load was up more than 75%. Now after the load will be removed in 60 seconds, then these replicas will come down based on the HPA configuration which we just did, and the HPA says that the scale down behavior says that after the stabilization window of 30 seconds, reduce the number of pods every 30 seconds. So that's what we will see happening here based on the utilization. So now utilization has come down. The load has also been removed. This time it has fired 8,400 requests in 60 seconds. So after the load is removed, we will start seeing the reduction in the pod. So you see every 30 seconds it will stop one pod, it will terminate one pod. So this is the configuration that I wanted to explain on horizontal pod autoscaler. Using this, you don't have to worry about taking care of the resources manually. Once you set up horizontal pod scaler, it will automatically take care of scaling up or scaling down based on the scale up, scale down policies that we define. Alright, so now we know that these applications are running with some resource limit, and that resource limit we had defined earlier. So let's see the YAML of this pod, and we see that the containers are running with this resource limit, which says that the CPU should not be less than 20, CPU request should not go beyond 50 millicore. It can go to less than 20, but it should not go beyond the 50 millicore, and the memory should not go beyond 64. So that's how we are limiting the resource uses for this application, which is the best thing to do. But what if in certain cases there are multiple developers working on this cluster? So what if the developer completely forgot to define any resource limit? In that case, this deployment will become a privileged disruptive deployment, because if in case the load increases, this deployment can take the whole cluster resources. So let me try to show that behavior from the administrator perspective, how we can take care of such deployments where the resource limits are not defined. So let me edit the deployment first and remove the resource limits that is set up on this container. Alright, so that now this application is running without any resource limit. As I said, in this case, the resource metrics can go up to any CPUs which are available, any memory which is available in the cluster. So as an administrator, I don't want that to happen. So what I will do, I will go to the administrator perspective in OpenShift, and I will define the limit range for this namespace. So I'll select the namespace, I'll define the limit range, and I want to define the default request and default limit for all the containers running in this namespaces. This will apply only where the developer has forgot to, developer or any pod is actually running without setting any resource limits. So then the default value will be applied. So let me define default CPU request as maybe 20 millicore and default memory request as 32 MIB. And the default limit memory I want to define as 64 and the CPU limit as 100 millicore. Okay, so once I define this, so a limit range is defined by which sets the default requests and default limits for any applications which has forgot to define the resource limit. So this way I am restricting any deployment and making sure that all the deployments, if they have not defined the request limit, it will run with my configuration. So now I go back to the developer perspective and try to restart this application where there was a resource limit undefined. So I'll delete this pod, which will create a new pod, and if we get to see the YAML of this new pod, we should see the default limit that should come from the limit ranges. So there you go, you see the exact values which was set in the limit range. So limit range has the default section, that is what is set. So now you can also see in the metrics that the memory uses is 32 MIB, 64 MIB. It has to be maximum of 64, and similarly the CPU can be maximum of 100. So this is for such cases where where a pod is completely running without resource limit. So we have defaulted that using the limit range. Now what if after this a developer thinks that okay, I should define always something in my application. So let's define 4 CPU as the max CPU limit that they want. They can set a very higher CPU and memory limits. So in that case, to restrict that to happen, to avoid any misuse, as an administrator, I will go back to the limit range that I defined, and I will set up the minimum and maximum values that anyone in this namespace can define resource limit for their pods. Okay, so I will go to the limit range and I will add a certain min and max values. So now this, by doing this, administrator is setting a hard limit. Remember, a hard limit for any application to run in this namespace. So what essentially this administrator is telling to the all the developers is that you cannot request less than 20 millicore CPU, and you cannot request less than 32 MI resources, memory resources, and similarly you cannot set up beyond 100 millicore CPU and 64 MI CPU. So let me show what happens if a developer tries to set below this minimum request. What should happen? They will not be allowed to deploy their application. So remember, the minimum we have just defined is 20 millicore. So I will go back to this application and I will try to request 10 millicore. Okay, and max is 50 millicore and 32 MI memory request and 64 MI memory request. So I'm just trying to deviate a little bit as a developer and trying to request less CPU than what is defined in the limit range. So it will immediately throw an error that this pod is forbidden and minimum CPU uses per container is 20 millicore, but what you have requested is 10 millicore. So due to this mismatch, this developer's application will not be allowed in this namespace. So for that, the developer has to change the resource limit and correct it to maybe 30 millicore, which is above 20 millicore, so but still below the limit defined. So this way he will be allowed to run their application. So that's the power of limit range. So using limit range, you can define for each container what are the min and max values and the default min and max values, default request and limit values. But what can happen after this? Okay, developer is complying to all these values per container, but the developer can create multiple containers or pods in their environment. So when they create multiple containers or pod, they can also go beyond the limit. They can create thousands of pods or containers based on the loads that is coming to their application. So in that case, again, as an administrator, my responsibility is to ensure that the cluster doesn't go out of resources. So I will define resource quota in that case. And what resource quota does, resource quota will be created for this particular namespace, and in that resource quota I will define the resource limit that can be created in this namespace. So I will define that no more than 10 pods will be allowed, no more than one CPU request is allowed, and so the request CPU that can be allowed should be between 1 and 2. It should not go beyond 2, and similarly the memory should not go beyond 2 GB. So this is as you can see, this is the hard limit. So if I define this, I will see that the number of pods is way within control. So only one pod is running right now, and the max I allow is 10. And the request CPU and memory CPU is also much within the control, and limit CPU and limit memory is also within the control. So this is another view. If you look at this table here, resource quota details. So all these request and CPU that we have defined is mentioned in the right hand side of the column, which is max. So that is the limit for everything: requests, limits, pods. There are more parameters that we can look into the documentation, and the used value is the current usage of this namespace. So this namespace is running only one pod right now with this limit and request of resources. Alright, so this way everything is safeguarded. Your application is, in the application you have defined the resource limit. You can also define horizontal pod scaler. You can, administrator has set limit ranges, so in case if I forget as a developer to define a resource limit, limit ranges will be in effect, and the resource quota will take care of the total number of pods running in this namespace, that it will not breach the maximum limits that is defined in the resource quota. Yeah, so that's how it works, and more can be seen from the documentation. If you go to the develop building application, under building application you can go to the quota, and there you can see how the resource quota per project can be defined. There is also an option of resource quota across multiple projects, so that also can be defined. And these are the various limits that you can define. So you can define number of pods, replication controllers, how many services that you allow, how many secrets that you allow within this namespace. So all these things can be defined. So read the documentation for more details. There is more documentation available under manage, nodes, and if you see the working with pods section, you will get to see the HPA related documentation, automatic scaling pods with original pod scaler. So it is recommended that you use deployment object or replica set object unless you need a specific feature or behavior provided by the other object. So the best practice is to set up HPA on deployment or replica set. The metrics will always be CPU or memory, based on which the HPA can happen. Alright, so the documentation explains a lot of details which you can go through later. There is one more documentation section I want to point out is working with cluster. Under the working with cluster, we will see the limit ranges, how it can be defined, restrict resource consumption with limit ranges. So here you will see more details on how you can set the limit ranges on container or pod. There is also something called max limit request ratio. So this is limit divided by request ratio. So that also you can define if you want to have a good space between the limit and request that this application is requesting. Alright, so that's all I wanted to show in today's videos, where we went through all these key object configurations to manage the OpenShift resources. Thank you.